A city wakes up to the sound of traffic, construction, and routine. But on one ordinary morning, a single sound slices through the noise. A metallic snap, followed by a scream, and then silence. A suspended scaffold, hanging 20 meters above ground, suddenly drops on one side. Two workers cling to the platform. One loses grip, and within seconds, a life is gone. Today on Workplace HSE Explained, we uncover the HIRA behind a fatal suspended scaffold collapse, how a simple oversight turned into a deadly chain reaction. Before we dive into the technical layers, pause for a moment. Think about how many suspended scaffolds you've seen on building facades. They look stable, almost harmless. But behind that illusion lies a system that depends entirely on ropes, winches, counterweights, and human judgment. One weak link, one missed inspection, one shortcut, and the entire structure becomes a trap. In this four-part series, we break down the collapse step by step. Part 1 sets the stage: the site, the crew, the equipment, and the early warning signs no one noticed. Part 2 exposes the hazards and risk ratings that should have triggered immediate action. Part 3 reconstructs the collapse moment by moment. And Part 4 reveals the HIRA that could have prevented the tragedy, ending with lessons every workplace must remember. Our story begins at a high-rise renovation project. Two facade painters were assigned to work on the 14th floor using a motorized, suspended scaffold. The equipment was rented, the ropes were old but usable, and the counterweights were assembled the previous evening. The supervisor signed off without a functional test. The workers trusted the system. They stepped onto the platform at 9:12 a.m. Minutes later, the left hoist began making a grinding noise. A vibration ran through the platform. One worker mentioned it, the other shrugged. They continued working. No one knew that inside the hoist, a worn-out brake mechanism was moments away from failing. No one realized the counterweights were not locked. No one checked the rope for internal fiber damage. This is where the story truly begins. To understand how the collapse unfolded, we must dissect the hazards that were present long before the scaffold lifted off the ground. Suspended scaffolds rely on a delicate balance, mechanical integrity, proper anchorage, and trained operators. When any of these weaken, the risk skyrockets. In this case, multiple hazards were silently stacking up. The first hazard, rope deterioration. The wire rope had visible rust patches, flattened strands, and uneven tension. A proper pre-use inspection would have flagged it as unfit. Risk rating, high likelihood, severe consequence, extreme risk. Yet it passed unnoticed. The second hazard, hoist malfunction. The grinding noise heard earlier wasn't new. Workers had reported it the previous week, but maintenance was delayed. A hoist with a compromised brake system is a ticking bomb. Risk rating, extreme again. The third hazard, improper counterweight installation. The counterweights were stacked but not locked. A sudden shift in load could cause imbalance. Risk rating, high. The fourth hazard, lack of training. One of the workers had only 2 days of experience with suspended scaffolds. He knew how to operate the controls, but not how to identify early signs of failure. Risk rating, high. The fifth hazard, no tag system. The scaffold had no green tag, no red tag, no inspection record. It was simply assumed to be safe. Risk rating, extreme. Individually, each hazard was dangerous. Combined, they created a perfect storm. A proper HIRA would have identified these hazards, assigned risk levels, and demanded controls: rope replacement, hoist servicing, counterweight locking, operator training, and a mandatory inspection tag. But none of these controls were implemented. The workers were left to rely on instinct instead of engineering, and as they continued painting the facade, the scaffold was slowly drifting toward failure. The vibration grew stronger. The left hoist struggled. The platform tilted slightly. These were warning signs. loud ones. But without training, without supervision, without a culture of safety, the signs were ignored. The collapse was no longer a possibility. It was inevitable. At 9:27 a.m., the platform jerked. The left hoist emitted a sharp metallic snap. The workers froze. One pressed the emergency stop, but the hoist was already beyond control. The brake mechanism, worn down from months of neglect, failed completely. The left side of the scaffold dropped half a meter in an instant. The sudden tilt threw both workers off balance. One grabbed the lifeline, the other stumbled toward the edge. The platform swung violently as the right hoist struggled to compensate. The counterweights on the left anchorage point shifted. They were never locked. The entire system destabilized. Within seconds, the left rope slipped through the hoist. The platform tilted to nearly 40 degrees. Tools slid off. A paint bucket crashed to the ground below. The worker who lost balance tried to hold onto the guardrail, but the angle was too steep. He slipped, falling 14 floors. The remaining worker clung to his lifeline, suspended in mid-air as the platform dangled unevenly. Rescue teams rushed, but the damage was done. One life lost, one life traumatized, a scaffold destroyed, a project halted, a family shattered. Investigators arrived within hours. Their findings were brutal. The rope had internal fiber damage. The hoist brake was worn out. The counterweights were unsecured. The inspection tag was missing. The supervisor had not conducted a pre-use check. The workers were not trained. Every root cause pointed to one truth: the collapse was preventable. Human factors played a major role. Production pressure pushed the team to start early. Maintenance delays were tolerated. Workers were afraid to report defects repeatedly. Supervisors assumed equipment was good enough. Safety culture was weak, reactive, and inconsistent. The collapse wasn't caused by one failure. It was caused by many small failures that aligned perfectly. A classic example of the Swiss cheese model: every layer of defense had a hole, and on that morning, all the holes lined up. This is why HIRA isn't paperwork. It's a shield, and when that shield is ignored, tragedy follows. Now that we've reconstructed the collapse, it's time to break down the HIRA that should have been conducted. A proper hazard identification and risk assessment would have flagged every weakness in the system before the scaffold ever left the ground. Hazard 1. Rope damage. Risk extreme. Control. Replace rope. Conduct tactile inspection. Ensure manufacturer-approved diameter and load rating. Hazard 2. Hoist malfunction. Risk extreme. Control. Scheduled maintenance, brake testing, load testing, and tagging. Hazard 3. Unsecured counterweights. Risk high. Control, locking pins, anti-slip plates, supervisor verification. Hazard 4. Inadequate training. Risk high. Control, certified suspended scaffold training, emergency drills, competency assessment. Hazard 5. Missing tag system. Risk extreme. Control, daily inspection tag, color-coded status, supervisor signature. Hazard 6. Poor supervision. Risk high. Control, mandatory pre-use checklist, documented inspections, escalation procedure. If these controls had been applied, the collapse would not have happened. HIRA is not a formality. It is a predictive tool. It tells you what can go wrong before it goes wrong. It forces you to confront risks that hide in plain sight. As we close this 4-part series, remember this: suspended scaffolds don't fail suddenly. They fail slowly, quietly, through ignored warnings and missing controls. Every worker deserves equipment that is inspected, maintained, and safe. Every supervisor must enforce checks without compromise. Every organization must build a culture where safety is not optional. This is Workplace HSE Explained. reminding you that behind every incident is a lesson, and behind every lesson is a chance to save a life. Stay alert, stay trained, and stay safe.